Yeah, well, hello and welcome to Local African Tutor. Today I'm going to be talking about the concept of mole. M-O-L-E. Mole. A mole, by definition, can be defined as the number of atoms as contained in 12 grams of carbon 12. In a more recent definition, they define mole as containing as a substance or an element that contains 6.022 times 10 raised to power 23. All right, these are the definition of mole we are going to be working with. But then again, I want to, anytime you think of mole, think of the word dozen. As we all know, dozen is a word or a word used for measurement, and we all know that it's 12. Now I want you to ask yourself a question: who chose this number 12 to be dozen? Somebody just woke up early morning and chose 12 out of 1 2 3 4 5 6 7 8 9 10. Somebody chose 12 as dozen, and now we use 12 for everything. Give me 12, give me a dozen of egg, you count 12. Give me a dozen of spoon, you count 12 spoons. We've been using that number particularly. So in the same vein, mole has its own reference. This 12 is like a reference point. Mole has its own reference. And scientists of those days chose carbon 12, 12 grams of carbon 12 as the reference for mole. Meaning you want 1 mole of any other element. What you have in 12 grams of carbon, count it for that element. Like, in essence, what they're trying to say, if you get a weighing balance, you get a weighing scale or something, a weighing machine, and you put a bowl on it. Let's say this is a weighing scale. You now measure 12 grams of carbon. Let's say this is carbon, a lot of carbon inside. Picture it maybe like sand, plenty sand, you understand? Or something else, not sand. Sand is more of silicon or something. Alright, you now measure 12 grams of this. You measure it, you count whatever is inside. Whatever you get from that 12 grams of carbon 12, remember it's carbon 12. There's isotopes, there's what they call isotopes of carbon. There's carbon 12, I think there's carbon 13 and like that. Those are isotopes of carbon. But you take carbon 12, the one that they called carbon 12, just it, you understand? You measure 12 grams of it, you count whatever is inside. Whatever you've counted, that is your reference point. So mole will now be that particular amount, just as dozen is 12. Whatever you counted for carbon, that will now be your reference, and use it for every other substance or element. Now, from the second definition, scientists have already done that counting for you. They've counted what is inside, the number of particles you will get inside 12 grams of carbon, and they counted it to be this figure: 6.022 times 10 raised to power 23. If I open this figure for you, it will be like in standard form now. This is in standard form. If you open it to normal form, it's like 6 and 20 zeros. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 zeros. So just as you have, what do you now call this figure? This is not million. It can't be million, it can't be billion, it can't be trillion. It's something, I don't know what you call this. Maybe check it up in the English dictionary. But this is way too big. And this amount, this figure that we got from 12 grams of carbon, that will now be our reference point. So you put this in here, that plenty, and so on and so forth. Meaning that if you want 1 mole of any other substance, count this amount. count this figure and give the person. That would be 1 mole. If you want 2 mole, count 2 of this and give the person. Just as you want 1 dozen of anything, you count 12. You want 2 dozen, you count 24. Like that. So that is what this statement is telling you, that 12 grams of carbon 12 is our reference point. They chose it as reference point. Out of all the elements, they chose carbon because it's more stable as the reference point for the measurement of a mole. And you agree with me that 1 dozen of eggs, 1 dozen of eggs, you get 12 eggs. Let's say this is the bowl, you get 12 eggs inside. And 1 dozen of spoons, you see 12 spoons. This is the bowl, you have spoons inside, up to 12, right? You agree with me that they are not the same weight. They are not the same weight. You have 12 eggs and 12 spoons. It can never be the same weight, even though they are both 1 dozen, but they don't have the same weight. So in the same vein, mole also, if you get 1 mole of oxygen, and that means you have to count these 6 whatever value, 6 trillion, billion, or jillion, I don't know what you call this. You have to count 6, that figure, 6.00, that plenty figure. And 1 mole, if you compare it 1 mole of any other element, let's say nitrogen, you still have to count that figure. If you calculate their weight, I don't know whether you are getting this. If you calculate their weight, it can never be the same. This one will give you 16. Let's say this one will give you what will it give you now? This one will give you 16 grams. Yes, that's for oxygen. That 6.0 times 10 raised to power 23. If you get their weight, this one will give you 16 grams, while this will give you 14 grams. It cannot be the same weight. Just as these two are not the same weight. 1 dozen of egg is not the same weight with 1 dozen of spoon. So to save us all the stress of counting this, maybe your guy comes and asks you, please, my guy, please give me 1 mole of carbon. You now start counting this whole plenty figure. Start counting these lots of figure. You get tired. Just 1 mole, you start counting this. 2 moles will now be what? So to save us all the stress, 1 mole of all this, from hydrogen down to other elements, 1 mole of it, scientists have already counted this amount of 1 mole of all those substances, and they've measured it, they've gotten their weight, and that weight is now the atomic mass. Or you can say the molar mass. So you need 1 mole. Instead of going to count this plenty figure, all you need to do is just know the atomic mass or the molar mass. Take for example carbon 12. Carbon is 12 grams. This is 1 mole of carbon. And in fact, that's why the unit says gram per mole. 2 moles will be 24. Chlorine, the atomic mass of chlorine is what? 35 gram per mole. This is 1 mole. So meaning their molar mass or atomic mass is just, they counted this figure of those elements and measured it and called it atomic mass, so that somebody comes to ask you, please give me 1 mole of something, you don't have to waste your time counting this reference that they gave you of that particular thing. All you need to do is just know the molar mass and measure it on your weighing scale. If you measure it, like if you pour in chlorine inside here, once it gets to 35 grams, that is your 1 mole. So I hope we understand this explanation. It's very important you understand this concept and the explanation behind these things, because as you go higher in chemistry, if you don't really understand the basics, things becomes much more difficult for you. So I'm going to be doing more videos. The next one I will do is on molecule. People have been having wrong concept about molecules, so I'm going to explain it. So please, if you have any questions or whatever, drop your questions in the comment section below, and I'm going to explain to you. All right, thank you.